Welcome to another episode of me trying to figure out how linked lists work by explaining them. Hopefully it works. Let's see how we go. So running through week 8 labs again is some of the introductory of working through linked lists, and some of these exercises including printing out elements of a given linked list. We're going to be working on inserting an element at the head of a linked list, and also inserting a tail. And these are some of the given append and prepend parts of the code they've given us. So the first thing we're going to do for our first exercise is we're going to copy over our given function. I just made a lab 8 folder. Okay, and let's get it up to gedit. Or get it, however you say it. I prefer to say get it, gedit. Anyway. So, first thing we do, always name and ZID. And our date is way too close to the exam. That would be the 16th of the 8th, 2019. Look at future people. Okay. So, what I always do is, when I look at these sorts of questions, I want to break it down into what we have, what it's asking us to do, and what we need to essentially do to get what we have, from what we have to what we need to do. So our task is to do some sort of operation on a linked list, this being a void that isn't returning anything. So it's just changing elements or taking out elements of a linked list. So the print is given an argument, and that points to the head, that points to the first node in our linked list. Here's what it's wanting to print. So we have our first element, and then there's the arrow operator, a space and an arrow operator, and then a space in the second. So the first thing I like to do is, looking at these desired outputs, is seeing what the difference will be with all of this. So we have a 1, a space, an arrow operator, and a space. Now that runs all the way until it points to X. Now, the way I interpret this is actually physically giving us interpretation of a linked list. So X is null, is the last of the linked list. So, let's have a look at what we've got here. So we have strings to list is running through. If we actually have a look at strings to list, this is a very useful bit of code for creating a linked list if you don't know how to create a linked list. So I'll quickly go through how this works as well. So first thing we do is we are creating a head which is of type struct node pointer. So that is a pointer that points to node. And at the moment, we're going to make that equal null. So that's not actually linking to the start of a linked list. In fact, it is a linked list because we haven't done anything yet. So we're defining an I, which is less than the length of the list that we're giving us. They're actually using a for loop here, which is not in the CS1511 style guide, which is interesting. But we just know that what this is doing is this is going to be running through until it reaches the end of our length. We're going to create nodes n, and we're going to have that malloc. So the reason why we malloc here is because we want to use it after this simple function, the struct node function. So we're going to go malloc. We're going to create it, use the memory, and then we can keep accessing this part, which is actually accessing the linked list. So the first thing you do is you have an assert test here. So assert will either keep running if it's true, or not run if it's not true. So we have if n is not equal to null. So what will happen is that the program will terminate if n now is empty, because it's saying that we haven't actually done the malloc correct, and that might be a problem if we haven't done things like including standard library, or if we haven't fed it in from the command line or something along those lines. So the next thing is basically our next pointer is going to equal head. So basically what we're saying here is we're feeding in a node n, and then we're going to make its next pointer point to head. But head is null. So basically we're pointing this to null. And then so that actually acts as a temporary node variable until we finish with our linked list. And then and data will be equal to our strings vi, and then we're using an a to I here. Now, if you don't know what a to I does, essentially what it does is it takes in these characters and it turns it into an integer values. So our data will be actually of int type, because this is an array of char stars. Char star is the array. And then at the end, a head is now going to be reinitialized to n. So that's going to be the end of the list. And it's going to keep going through until we've hit the end of what our input is. That'll be the list. Okay, so that's what our strings to list will be doing. So let's think about how we're going to print it. So once again, this is going to be basically running through a given linked list. So this is just giving us a pointer to the head of our linked list, and we're going to run through until null. So as we can see here, head has always been put at the top of the linked list, and then we push it back through, and then we keep going up and up. And that'll be evident once we start running through this. So I always think the first thing we need to do is we need to create some sort of node pointer. I always like to call it cur. Some people call it current. I think cur is just a bit more simple. We can actually equate that to head. So what we're saying here is that we're pointing cur at the top of the linked list. And we have to do some sort of operation on cur to push it through until we run through the end of the linked list. And what we can think about that is that we actually want it to print to the end of the linked list. But at the end of the linked list, we've got to think about where that last element's next pointer points to. And that actually points to null, which isn't in the linked list. So there's a little caveat we'll figure out in a sec by running through. So what we were doing before is we're running so while cur isn't equal to null, and incrementing it by making cur equal to cur next. But the problem that we're going to run into here, and then the assumption what we'd printf essentially a number and then an arrow pointer. So it would be integer value space arrow pointer, and I believe that's what it's saying there, space arrow pointer space. Yeah, arrow pointer space. And then we'd be not doing a new line, always remember that, easy to fall into that habit. And we'd be saying our cur data, which our data would be fed in from up here. here, because we're actually feeding in the pointer of the struct. So this struct node, it looks like it's only got one thing, not data, head or next or anything, but it's got next and data, so we can utilize those things. So it's going to be cur data. But if you can think about, this isn't actually going to work. And then obviously at the end, we want to print off x again, because that will be indicative that we've reached null. Now, if I were to run this, however, we're going to have either a compiling error, or actually think it might be a runtime error. And I'll explain that in a moment. But let's have a look and see what it says first, just in case there's any other issues with our code. You know, we might be missing some brackets or something along those lines. So I've got the dash O. We can obviously run this with a bunch of other error checks, leak checks, etc., but because we're not actually mallocing anything. Let's print. I'll write it the long way around. Let's just rewrite this here for a second. I'm going to call this. I'm just going to do the whole thing again. Print list. No, list print. I apologize. Getting late. My brain is turning off bit by bit. List print dot c. Okay, that seems to compile. But now, if we actually, hey man, here. If we actually were to run this though, we're going to be getting a runtime error. And in fact, we're actually not going to be printing the last element of the list. So if I were to copy over some of the given command line functions, for instance, here, list print. If I were to paste in these command line functions, you'll be seeing that it won't be printing one of the elements. And in fact, let's just copy this right over. Problems with actually pasting it in. And paste. So we've got 1 running through to 256, and it's actually pointing to n. Okay. What I was thinking was that, in fact, we wanted to go through to the second last before accessing null. And we could also do that by actually utilizing data. So that's if instead of printing x, we wanted to print, for instance, null. If we wanted to print the pointer, the value the pointer is. So instead of running cur till null, we want to say when we're at the last element. So that's when our next pointer is still not equal to null. So that'll be the second last element. And instead of saying print f here, let's print our %p. And while we're at it, I have to put in a new line as well. And we want now our cur data. Let's see what would happen there. And you can see that we're actually printing through, and then we're going to be printing the pointer of cur here. And in fact, this will be more evident if I were to do it like this. It's pointing to nil. So nil is actually a position in our memory space. Some brain juice. And I'd be pointing them. I could actually, if I were to say %d, if I were to say then cur data, we're going to have error because there's no data at null.